Let's look at another application of law of sine. Again, we want to solve for all possible triangles with sides A is equal to 50, B is equal to 100, and angle A is equal to 50 degrees. Let's first draw our triangle. Here is our triangle with our angles labeled, and the only angle that we're given is A, which is 50 degrees. And here are the sides. We're given two sides, A, which is 50, and side B, which is 100. So we want to use the ratio of sine of A divided by A to solve for angle B. And by the law of sines, this is going to be equal to sine of B divided by B. Plugging in 50 degrees, we'll get sine of 50 degrees divided by 50 is equal to sine of B divided by 100. Multiply both sides by 100, and we're left with 2 times sine of 50 degrees is equal to sine of B. Plugging sine of 50 degrees into a calculator, we'll get that this is then approximately equal to 2 times 0.76604, which is equal to sine of B. On the left-hand side, we see that this is going to be approximately equal to 1.532096. And we reach a contradiction. Since the range of sine of B is between 1 and -1, and we have up here that the only solution that makes this true is when sine of B is outside its range. This is what gives us our contradiction. And what this tells us is that there's no possible triangle with these given sides and angle A. We'll now look at one more example. Again, we're going to solve for all possible triangles with given side information and given angles. Here we're given side A is 7 times the square root of 2, side B is 7, and angle A is 45 degrees. So filling out our triangle, we have one angle, which is 45. The opposite side A is 7 square roots of 2. We don't know what B is, but we know what side B is. This is 7. And we don't know angle C or side C. Since we know side B, we can use the ratio of sine A divided by A to find our angle B. Plugging in what we know, we get sine of 45 degrees divided by 7 square roots of 2 is going to be equal to sine of B divided by 7. Multiplying 7 on both sides, we get sine of B is going to be equal to sine of 45 degrees divided by the square root of 2. Simplifying the sine of 45 degrees, this is going to be equal to 1 divided by the square root of 2 times the square root of 2 divided by 2. And we're given that sine of B is equal to 1/2. Now, we know that sine of B is equal to 1/2 when B is equal to 30 degrees. We can show this using inverse trig functions. Furthermore, we know that another solution of this will be an angle B whose reference angle is 30 degrees in the second quadrant. So B in this case is either 30 degrees or 150 degrees. Now we can actually cross out the possibility of B being 150 degrees by the fact that the sum of our angles A plus B plus C has to be equal to 180 degrees, but the sum of angle B at 150 degrees plus angle A is greater than 180 degrees. And so we can toss out 150 degrees. But we found that B is 30 degrees, A was given to be 45 degrees, which means C is going to be the remainder, which is going to be 180 minus 75. In the last part of our problem, we need to go ahead and find side C, but again, we can go ahead and use the ratio of sine A divided by A to find what side C has to be, since we know what the angle of C is. Using this law of sine, the ratio of sine of A divided by A is going to be equal to sine of C divided by side C. Then side C is equal to A times sine of angle C divided by sine of angle A. This gives us that C is equal to 7 square roots of 2 times sine of 105 degrees divided by sine of 45 degrees. Simplifying this is equal to 7 square roots of 2, where we multiply by sine of 105 degrees divided by the square root of 2 divided by 2. Simplifying this again, our square roots of 2 cancel out, our 2 comes to the top, and we're left with 14 times sine of 105 degrees. Plugging this into a calculator, and we see that C is approximately equal to 13.522. So we found our angle B, we found our angle C, and we found our side C, which means that there exists only one triangle that meets the initial conditions.